Hey everyone. Okay, so I'm going to be doing day 2 of Advent of Code 2020, COVID edition, as sort of like a live recording. This is the first time I've ever done anything like this, so you'll have to excuse me if I mumble a lot or forget that I'm recording, that kind of thing. I'm going to be doing it with literate CoffeeScript this year, which is kind of a neat format. For those of you who aren't familiar with it, it's basically like a markdown document with embedded code. So anything within a code block will run. The reason I want to do that for this is because I like CoffeeScript. I appreciate the terse syntax of it. I like white space sensitive languages. And I'd like to do it specifically in literate CoffeeScript because it produces a document that I feel like would be a really good fit for something like Advent of Code, where you can have the problem statement, you can have your inline, like test cases, and you can actually write down things about like reasoning behind why you're doing certain things. Anyway, I've sort of like, I started with just regular CoffeeScript, and then I refactored day 1 into literate CoffeeScript, and I was pretty pleased with the output. So yeah, I'm gonna give that a shot. All right, so let's take a look at Advent of Code day 2, which I haven't looked at yet. Okay, day 2, password philosophy. Okay, we are going somewhere via toboggan. Okay. Shopkeeper of the North Pole is having a bad day. Something's wrong with their computers. Their password database seems to be a little corrupted. Okay, so that doesn't sound good. Try to debug the problem. They have created a list, your puzzle input, of passwords according to the corrupted database and the corporate policy when that password was set. Okay, so for example, suppose you have the following list. Okay, each line gives the password policy and then the password. The password policy indicates the lowest and highest number of times a given letter must appear for the password to be valid. So, okay, 1 to 3 means that the password must contain at least 1 time and at most 3 times. Oh, it must contain a at least 1 time and at most 3 times. Interesting. In the above example, 2 passwords are valid. The middle password is not, presumably because it doesn't contain 1 to 3 Bs, because it contains 0 Bs. Okay, the first and the third passwords are valid. They contain 1A or 9C. So between 2 to 9 Cs, both within the limits of their respective policies. How many passwords are valid according to the policies? Wow, okay, interesting. So cool. So let's copy this and we'll make some new files. So let's copy day 1. So I usually do a folder structure, and I'll show you what that looks like. Basically, I've got part 1 in its own file, part 2 in its own file, and then I put the puzzle input into a different file. So what I'm going to do is I'm just going to open up part 1, and I'm going to replace this markdown with what we got here. So this is going to be like that. And then I like putting these in their own little code blocks. Cool. So then we've got these definitions. So this is all the day 1 work. Tests, I'm just going to comment those out and then run. We don't care about that. All right, so this is to give you an idea of what it looks like in Markdown. This is basically what it's going to look like. We're going to have the problem description up here, and then we'll have our actual type defs, and then our tests, and then finally it'll run. Github actually does some nice code formatting or code coloring, so you can get the nice code output. And this preview doesn't really show that, but it's pretty good for just kind of getting a general idea of what it's going to look like. Okay, so we need to prove that the first and the third examples are valid, and we need to prove that the second one is not valid. So, all right, let's take a look at that input. What does that input look like? So let's copy this input. I like to copy this input here. Okay. Oops. Okay, so these are the lines that we're going to get in. We're going to get this rule, and then this character, and then a colon, and then the password string. So it looks like no matter what we do, we're going to have to parse this into its constituent parts. So we've got the repetition rule, we've got the character, and we've got a colon and space, and then the string to test against. So this looks a lot to me like effectively a regex. Like, this is, how would we do this in regex? Like, we would probably do something like, we would take the string. So we take this string and we would do, does this, like, does a regex match this? So test. So we would do, you know, A 1 to 3, test that. So let's assert that is true, and let's just give this a run and see what this does. We need to see day 2 and coffee 1 dot late coffee. So that actually passes. That's really interesting. So let's see if it fails now. Actually, I think, can I do some sort of like isn't there like a build command tool? Build with, no, I don't want that. Build system. Let's try that, and then let's try CoffeeScript run, if we can just do that. Okay, so that actually, interestingly, fail. Oh, right, because we changed it to fail. So let's now put the A back, and we'll build it again, and it works. Okay, wow, okay, so this is really great. So that means that in this case, we should assert, is there not equal? Is that how that works? Equal, and then 1 to 3, and it was a B, and we're gonna test this string. Interesting, so actual, oh, not equal. That's, so we wanna assert not. So I forget how to do that. Node.js assert. Let's find assert. Is there like a don't assert? I always forget. Assert fail. Okay. Interesting. Oh, there's also assert match. Interesting. So maybe I can do that. So I can do assert dot match and assert. I'm guessing here. I don't know if I saw not match, but we're going to try that. Comma. Okay, let's build that. Assert match is not a function. Okay. Why is that? Assert. So this is assert. All right. So where's match? Does not match is that string regex. Okay. So I need to. This said it's not a function. That's super weird because I'm requiring assert here. So assert match. Oh, requires strict. Oh, that's interesting. Okay, well, we can try that, I guess. Match equals require. Oops. Assert dot strict. And we'll probably does not match as well. So let's try match and whoops, does not match. Match is not a function. It really doesn't like that. Oh, that's assert that we get back. Oh yeah, but that's super weird. Am I using the right node version? Oops. let's 12 npm use. Aha, that might be it. Okay, so let's try building this now. It doesn't like that. Maybe this is not using the same node version. Let's try here and say node 1 dot. Okay, so let's just do that from now on instead of hitting build. What does this say? Invalid or unexpected token. Oh, it's not a node, it's coffee. Coffee. Like coffee. Must be an instance. Okay, so now it's working, but it's saying that we've got the arguments in the wrong order. Okay. Let's try that. Okay, so that does work. Okay, so that's kind of cool with match and does not match, but I really don't care for that syntax. So I'm gonna go back and find out. We can do assert. We just want to invert assert. So I guess assert fail. The message for okay. So this one's require assert strict still fail. Boom. Okay. Throws an assertion error when the provided error message. If the message parameter is in essence actual expected. So it's just if it doesn't match, or maybe if it's not truthy, that's what I'm really hoping for. I'm hoping to find something that isn't truthy. So what do we have here? Strict legacy. Okay, so I guess assert fail is just the opposite of assert okay. That's what I'm assuming. So I'm gonna guess that that's the case. Is okay and fail. So this is gonna be assert okay, and then we'll test it. And then we'll do the same thing here. So assert dot fail test. Okay, then we can run that. Assertion error false. Which one? Was it that one? Yeah. What if we try to do that one? And that works. Assert fail. What if we try both of these? So okay, so fail doesn't seem to work. So actual expected. So maybe I can just do that true. So that's what I'm expecting it to be false. Is that correct? False is not equal to false. Okay, guys, listen. I'm just going to stop trying to be fancy with this and okay, and negate it. In fact, I can just not test config. All right, there we go. I'm okay with that. We'll stop fighting with assert today. Okay, let's try the third case. It's 2 to 9, 2, 9, and that's a C. Okay, beautiful. So now we're going to need to parse the input and get these values out of it. So we need the character, we need the repetition like the start and the end, and we need the string to test, and we can see if it's okay or not. So yeah, let's parse the input. What are we going to need to do? We're going to need to do lines equals parse input, something like that. So let's start defining parse equals lines, or I guess this is going to be a text block. And what we're going to do is we're going to basically just split it. Text.split, and we'll split it on a new line and we'll see what we get back. Okay, so we got log all there already, so we're gonna like log that. So these are the lines that we get down here. 1, 2, 3, that's what we're expecting. Cool. And then what we're going to do is we're going to, so this is kind of like parse input. And we're going to say parse input input. And then we're going to want to parse a line. Parse line equals, put the line in. And then, so what we're going to do is we're going to look for a number, a dash, and a number, space. Okay, let's just write it down here. So we're going to need a digit, a literal dash, I think that's fine, digit, space, a word character, a colon, I don't think I need to escape the dash of the colon, another space, and then a bunch of word characters. Okay, so this is going to be capture group, space, capture group, and capture group, like that. So let's see what we get when we parse the line. Okay, so for line in, and for that, we're going to log parse line, see what we get. Match line. Match is not, it's the other way, it's line dot match. I think you can do this with exec too, which is what we might end up doing. Okay, here we go. So 1, 3, A, oops. Okay. And index, input, groups. Okay, cool. So we're gonna want to say, okay, this is going to be the match equals that. And then what we're going to want to return, let's return an object that has range start equals match 1 equals range and match 2. What else is it? The character is going to be match 3. And in fact, there's probably a much nicer way of doing this. So start, we're going to have like nothing, start, and car and string. Oops. Equals match. And then we're going to return. So I'm just going to use destructuring here to clean it up a bit. Okay, let's see what that looks like. So start and, oh, interesting. Yeah, these are strings too. I really don't think that matters for what we're going to do, because what we're going to do next, I think, is we're going to create a regular expression, and then we're going to try and match it. So create a regex. Okay, so parse line. So parse line is now going to give us these objects back. So object equals whatever. So now what we want to do is we want to create a regex. So create regex with, we're going to pass it object.start, or yes, char object.start, object.end, and that's all we care about for creating the regex. Okay, so let's make this function. Oops, create a regex equals, and it's going to be char start end, and that is going to, I always forget what this is it JavaScript regex new, it is regexp. Okay, yeah, perfect, cool. And we can make it case insensitive if we want. So new regexp, new exp, and that is going to be, what did our regex look like? Down here, look like character. So that, like that. Okay, so this is going to be char. This is going to be, oops, start. I'm very confused with all these. Yeah, and then end. So this is this is our regex right here. Cool. Cool. And that is it. That's what we do. That creates a regex. So we create the regex, and then we want to test the regex. Object dot, what did I call it? String? Str. Okay. And let's log that and see what we get. Okay, so true, false, true. So this is perfect. This is actually mimicking what we get here, which is that this is valid, this is not valid, and then this is valid again. I'm not really a big fan of how this is broken down. It's kind of weird that parse input really just does this one thing. And I feel like maybe parse line is doing a lot of heavy lifting, and then it could just be creating the regex. But then we wouldn't have the string to test separately. I mean, we could do it all in one shot, but I don't like just having everything in line. Like I like to be able to break it up into methods like this. So I think what I'm going to do is I'm going to remove maybe parse input. I'm just going to where is it? So in input that. If I just split that into lines immediately, then we can get rid of this method here, and we don't really care about it. So parse line is still doing like some meaningful work where it produces this object that sort of like maps to all of these parts, like the beginning, the end. I don't like start and end either. I think these were really poor choices for words. So let's do min max, and then min, and then whoops. Whoop. No. There we go. Min max. Okay, that sort of feels a bit better, except these start and ends are not. This start is going to be min, and this is going to be max. So char min max, and we still have string. Another thing we could do is in parse line. What we could do is we could generate the regex in here and provide sort of like the mechanism by which we test it, as well as the string. So that is sort of like less functional. Well, before we do anything, let's just double check that this still runs. Okay, it does. Cool. So what would that be like? It's a bit more object oriented, I guess. So you could have like class password, and then that could constructor that could have sort of like the method by which you test it built into it, as well as the string itself that you're testing. So we could actually construct one of these things, and that would be kind of cool. So we could either fit in min max and char as the rule, and then have it construct its own regex and have it have its own test method. And yeah, let's do that. Why not? Min max and char, and then string. Cool. So that does those things. That will make them, so that would be a new, so p equals new password. And then, in fact, we don't need to return anything here. Parse line. And then we can have, so valid function, and that valid function would just say, hey, we need to create a regex, which does this. So let's make a regex function. Does this. Okay, so this is this dot char, this dot min, this dot max. So that would say this regex dot test string, like that. So now we can get rid of create regex. So this is going to return a new password object. Oops, these are not indented properly. It's going to return a new password object, and then password is going to have a valid function. So let's try that. So this is going to give us or password object, and the password is going to have this valid. So let's see, log password valid, and we don't need any of those things anymore. So let's see. Okay, so wow, okay, this is just working, which is very confusing to me. Usually anything longer than like a one-line refactor has a little problem somewhere. All right, and so we've got this parse line method. It's kind of weird that it's just dangling here. So what we can actually do is we can make this a class method. Parse. Or we could actually put that into the constructor. We could create whatever. Let's just make a class method that takes a string, or I guess, yeah, a line, and then it can create. There we go. So basically it's the exact same, it's just attached to the password constructor. So now we would say password.parse. All right, and it is still working. Okay, cool. Now we've got this nice little class that has all this stuff. And we can get rid of these things because we don't care about them anymore. So we'll probably want to assert that this works. So we can say password.parse. This is going to be .valid. So we can assert that that's true, and we can assert not that this is true, and we can assert that this is true again. Here, just go. Copy 2.9. All right, and we don't need that anymore. So is it still? Yep, cool. Still working. Cool. We don't need these. So I feel a bit better about this. I don't know what I would do differently, honestly. I think this is good enough for now. All right, so let's take a look at what it is. Each line gives you the password policy. Okay, good, yes. How many passwords are valid according to their policy? So in the example above, 2 passwords are valid. Okay, so the first and third passwords, good. So I guess the real question is how many are valid? So what we're gonna wanna do is we are going to want to assert that given this input, that 2 are valid. So we're gonna need a function count valid, and this is gonna take some text, and it is gonna do basically what we were doing before. So it's gonna do text split on new line, and then for line in that we're going to do new password line, and then we want to check if it's a password parse line, and we're going to check if it's valid. So if it's valid, we're going to need a counter num equals 0, and we're going to say num plus equals 1. Let's do that. And then we'll return num at the end. So count valid, we're going to assert dot equal. I think that's how that works. I forget. Assert equal that count valid input that 2 is that. So that was not. Password.parse is not a constructor. Oh, a new password.parse. There you go. Okay, so that worked. Cool. So let's just make sure that it fails. And it does. 2. Cool. So now what we want to do is we want to count how many down here we want to count valid of the actual input. So we're going to have to replace the input with the new input, which we're going to get from here. Cool. Get your puzzle input. Okay, so we've got our input. Okay. Cool. And we can say input equals wire. Oops. Put. Totally just overwriting the input variable just because it's convenient. And it's terrible. I'm going to do it anyway. And then what we want to do is we want to log whatever the valid number from the input is. So let's give it a shot. So something broke. I cannot find module input. I have to input.coffee and oh, there we go. So object null is not iterable. Cannot read property. Admin of code day 1, line 41. So it's saying something is not iterable. So something's not matching here. Okay, so that's really interesting. So something in here didn't match, and it's I can see what the problem is. It's because we have 2-digit numbers, and we never counted for 2-digit numbers. So let's fix that real quick. Over here, this is a decimal number, so let's say multiple decimal numbers, and we'll do the same here. And we've got one word character, which I think seems to be always the case. Okay, and let's give that a try. So 345, that's how many are valid. So let's give that a shot. 345. That's not the right answer. Your number is too low. If you're stuck, make sure the page you're using is full of. Okay, cool. Interesting. So that's not the right answer. So let's, if password valid. So let's print out some of these. So we're going to print out min, max, char, and string. Log here. P equals that. And then this is p.valid. And it's from that. So password. Let's just take a look at some of these. Okay, so 5 and 13 L's. So 1, 2, 3, 4. So this should be, I should also print out if it's valid. Log p, comma, p dot valid. Let's spell it right. Valid. Okay, actually, let's do p dot valid first so we know. So we can, there we go. So false. So yeah, it's saying the number is too low, which means that we are treating some as invalid when in fact they should be valid. So let's take a look at some of these and see if we are getting false negatives. Yeah, I don't know if this resets over time. Whoops. There we go. Well, I'll start at the bottom. Why not? False password. Okay, so this did not match. It should be between 4 and 5 C's, and there are 4 C's. Oh, okay, interesting. So this is immediately a failure right here. So why is that? So let's take a look at the regex. So char between 4 and 5. So what would that look like? That would be, okay, so let's just start testing right here. Assert new regex test, and what was it, CCCHC. So, oh my god, right. I was just looking at things in a row and not total number. So this regex thing is totally just not going to work. Right. So the problem is that the regex that I was constructing was counting recurrences in a row and not just how many are in the total thing. So this is totally not going to work. But it's a quick fix. Instead of creating a regex, what we'll do is we will just count the number of occurrences. So this is the nice thing about this structure, is like this valid function right now, it's constructing a regex and testing it, but I mean, we don't care about that. What we can do is we can just say, we want to count the number of times that something exists in the input and see if it's equal to or above the min, and see if it is equal to or below the max. So, all right, I wonder what the best way to do that is. We can filter the input string for just the character. Or we could just count them. So if we filter it, then we'd have an array that we can test the length of. And if we decide that we want to just iterate through the string and count the number of A's, then we can do that too, or count the number of characters, then we can do that too. What we could also do is we could maybe use the regex object. We could use a regex object to see how many characters there are. So let's take a quick look at that and see what that looks like. New regex, it's probably not the most fast way to do it. Yeah, let's just do simple count. So count equals 0, and we'll say cool for C in, what is it, string split on nothing if C is char. So we want to count plus equals 1 C is char, and then what we want to do is we want to see if count if this is going to be we need to parse in. I like parse float better because parse in you have to pass in the base, and I always forget to do that. So we're going to parse float min. In fact, what we can do is these min and max, we're just going to do min equals parse float min, and we're just going to do this in the constructor. There we go, and then we don't have to worry about it. Min is less than or equal to count, and max is greater than or equal to count. Count. There we go. In fact, we don't need to return anything. We can just say that. So let's see if this works. Okay, so this gives us true for 4 to 5 and false for 4 to 12. 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12. So it's over max. Okay, so I think this is probably it. So we've got a pretty basic idea here. Okay, if we see in string split. In fact, we can probably clean this up when, and then we can just say count plus equals 1. And okay, so this is giving us the number 447. So the easiest way for us to see if this is correct is just to put 447 in. Let's do that. Submit. You gave an answer to recently. What? Oh, did I? Oh, okay. I guess that was correct, and I just hit enter twice or something. Okay, cool. So that is part one. Cool. So we made a misstep there in not understanding the question, which has never happened to me before, honestly. Which happens all the time, and I should be more careful. So let's take a look at part two. So part two is no longer the accounting elves. Just clear up part. This is yesterday's work. Tests. We'll leave this stuff require input. I'll just leave that in there, and then these assertions we don't care about anymore. So part two, and we will properly read part two after I paste it in. Two. Okay, and then this is our input. Just gonna clean this up. Okay, cool. So part two. Well, it appears you validated the passwords correctly. They don't seem to be what the official Toboggan corporate authentication system is expecting. Okay, I should buy a toboggan. The shoekeeper suddenly realizes that he just accidentally explained the password policy rules from his old job and the sled rental place down the street. Okay, or at the sled rental place down the street. The official Toboggan corporate policy actually works a little differently. Each policy actually describes two positions in the password, where 1 means the first character, 2 means the second character, and so on. Be careful. Toboggan corporate policies have no concept of index 0. Oh, okay, interesting. Exactly one of these positions must contain the given letter. Exactly one of these positions must contain the given letter. Okay. Other occurrences of the letter are irrelevant. So given the same, okay, so this one is valid because position 1 contains the A and position 3 does not. Interesting. So position 1, position 3, so 1 is not a C and 3 is, or 1 is not a B, so that's invalid, and 3 is not a B. Okay, interesting. So we want to make sure that one of these matches and only one of them matches. Okay. Cool. So hopefully I understand that a little bit better than what I did the last time. So we're gonna let's keep some of our work from the last time and build on it. So we got class password, and that input is the same still. Cool. And we've got our test input. Have these changed? Yeah, they're the same. So valid, invalid, invalid is what it should be. This word. So it's going to be valid, invalid, invalid. So assert not. Okay. And then assert count equal 1 should be valid. Oh shit, this is not the right file. I'm going to close that one so I don't do that again. In fact, I want it back because I didn't copy it over. Let's just copy this whole test section. And we will, there we go. I should have just copied this file in the first place. I'm not sure why I didn't do that. So we want first is valid, second is not, third is not. We want the number of valid ones to be equal. Okay, cool. So now what valid means has changed. So I think what we want to do, and we can put these back. We deconstructed this for debugging, but we don't need to do that. This still works, right? 447? Yeah, beautiful. And we'll do the same thing here. Okay. Assertion error, false equals true. Right, okay, so this is breaking because we haven't updated what valid means. So really, I think what we want to do is we want to test, there's always going to be a first number and a second number, which we've called min and max. And we want to make sure that one of them, only one of them, is true. So we can say string, it's going to be at string of min, but it's not 0 index, so min -1. If that exists, is, I guess it'll be null. If not, is char. And, oops. Max -1 isn't char. So we want to do that. So it's going to be or. The opposite, whoops. Isn't and is char. So we could probably just do that. Oh, I don't like the or on its own line, but whatever. I think it's more readable. So still doesn't like it. Char. Oh yeah. Oops. All right. Okay, cool. So valid and require input, and what do we have down here? Yeah, just log count valid input. So let's just do that again. Oops, there we go. So 249. So we could do this. I know we could also probably do the same thing for like we could have the same logic expressed as like a binary operator. We could say like, was it true? Was it exclusive or? Maybe XOR in JavaScript. Bitwise XOR. Oh, it's the little carrot boy. So cool. Oh, let's give that a try. Let's see if that works. Is char, whoops, that or is char. 249. Okay, cool. So that's nice. So this is the first one is true, or exclusive or the second one is true, but not both. Cool. So 249. That's what we're getting. All our assertions passed because we got to the point where we counted. Just to test that, we can break it. Yeah. Oops. There we go. And beautiful. All right. Let's see. Oops. That's not what I want to do. I want to test the markdown. Yeah. Okay. Cool. Well, let's give it a shot. So 249 it says. Let's see if we read the question correctly this time. Submit. And that's the right answer. Nice. We are 1 gold star closer to saving our vacation. Sweet. And I guess that's it. So what do we do now? Let's take a quick look and see if we're still happy with the code that we wrote. So this is number 1, which gave us 447. Cool. So we're log and assert. We had a misstep with assert there, trying to use the fancy assert. But I find that just asserting that something's not true is just as easy, so that's fine. In both cases, we used this password constructor, and that was the case in both cases. And we parsed these numbers in the constructor. So valid for part 1 is just that we go through each character in the string and we count the ones that we care about. And then we check that that count is below the min and or below the max or equal to the max, or above or equal to the min. We could split this out into its own method if we wanted to, and let's just do that because why not? Count, and then char. Okay, so count equals 0. I guess we don't need to pass in char because we already know what the count is. So we refer count and count. Of course, this doesn't memoize the function unless we do like c equals count. And then, so let's see if that gives us the same 447. We could run this through a reducer to maybe clean this up a bit. We could dot reduce, and then that gives us, was it string memo? Is that how that works? And then we could, or this is going to be a char. Oh, got a split on nothing. And then char is, so we can say memo plus equals 1 if, like that. And then at the end we want to, now let's see, we'd want to, yeah, we're returning memo plus equals 1. Okay. Let's see if that works. Assertion false equals true. Okay, so something I did here. If, oh, C is C. Yeah, that's not, C is char. So that's not liking it either. Cannot read part, oh, right, because we gotta bind it. Still not liking it. Oh, because this one's not bound. That's why. This is a function here. False equals true. Whatever. Just put it back. It's just shittier because it's probably more readable, honestly. Okay, so what do we have? We got these. What do we change here? We just changed how we counted. And in this one, there is no count. So there's nothing to do here. And count valid. In both cases, we're doing the same pattern where we've got 0 and we've got this for line. I guess what we can do is we can get an array. We can filter this array by this condition and then return the length of it. But yeah, I really don't care. I don't think that's necessarily even more readable. This gives you a good idea that you're making a running counter and then you're returning the result at the end. If we try to get fancy with like do one-liners like filters, then I don't feel like we'll really gain anything in terms of readability, and I don't think it will necessarily even like work faster or better. So I'm going to leave it. I think honestly, I'm fine with how this worked out. Yeah. Okay. Let's leave it there. So what we do now is we commit our work. Actually, here I'll yeah, I may as well. How do you do this? That to desktop 2. There you go. So what do we got here? So the README, that was a mistake. Didn't mean to do that. I like getx. Day 2, that's part 1. Part 2, this is our input. Okay, day 2. Cool. I like getx because especially when you've got a diff, you can just sort of like visually inspect the diff and make sure that it is what you're expecting it to be. It's always good practice to sort of like review your commit before you push it. Cool. Okay, so let's commit that and we'll push that to GitHub. And when that's done, that means over here, we should have day 2 folder. And this is how it looks on GitHub. Well, that's interesting. I guess it expects that to be code rather than just a text block. But it's just the highlighter. It still runs fine. Okay, cool. So with that, I think this is pretty much done. Cool. So yeah, would love some pointers. This is the first time I've ever done anything like this live coding. We've pair programmed before, but not really with like a ghost. So yeah, if you have any tips on maybe how I could do this better next time, or how I could fix the recording if the recording sucks, would be much appreciated. Yeah. So I guess maybe I'll upload this to YouTube, and then you can leave a comment there, or you're likely coming from the Toronto.js Slack, so you can just hit me up on there, and any tips would be appreciated. So thanks very much.